Hey, this is Gabe with HTP. Today we're going to get into the ins and outs of pulse TIG welding with the 221 invert TIG. One thing that people like to figure out or want to know is a lot of people think that I should use pulse all the time and I should weld with pulse all the time. Yes, you can. There's certain instances where myself professionally, I will use pulse, and there's some instances where I don't use pulse. And we're going to get into that a little bit as far as when I would use it and when I wouldn't use it, what kind of settings I'll set up, what kind of joint I would use it in. Stuff like that will really get you so that you kind of understand pulse and then can make a decision on whether or not you should use it in a certain instance. So we're going to get a little into the pulse. A lot of the terms that I'm going to tell you probably aren't going to be industry standard. In order to understand it, I'm going to try to simplify it as best as possible. That way you can kind of figure it out and don't have to look up this word or whatever it may be. So essentially what pulse is going to be a high and a low as far as amperage. So let's say we're set at 100 amps, but our pulse background is 50 amps. It would mean that it's 100 amps, or 50%, I'm sorry. It'd be 100 amps, and it would drop down to 50 amps at a set time. So if you have your pulses per second set at 1, it would hit 50 amps every 1 second and jump back up to 100, and it would alternate back and forth depending on what your pulses per second. Your pulses per second are your on, off, almost like that. That's essentially what the machine is doing, is blasting current and coming off of it, but not coming off of it completely enough so that you kill the arc. That's all it's doing. So the pros for using pulse is you're able to get deep penetration in without the amount of heat input that you would get if you just were set at 100 amps. If you're at 100 amps and you mash the pedal down and start welding thin material, you're going to blow a hole through it. But if you have it 100 amps and whatever your background is, you can probably finesse thin material through. The biggest thing is understanding when I have pulse on, you kind of have to set the machine a little bit differently than if I have pulse off. If I'm welding, thin 20 gauge, whatever it may be, I may be, 75 to 100 amps. Whereas if I have pulse, I'm going to set the machine a little bit higher because you're alternating back between that high and low. So that's basically one of the things that you want to do. Pulse is good for thin material to keep distortion out of it. So if I'm welding, constantly without pulse on thinner material, you'll get potato chippy. A lot of times with pulse you can avoid that because you're not getting as much heat into the material. So that's one of the benefits with pulse. Another benefit is it looks cool. It makes your ripples more precise. So it really gets your timing going well with pulse because it's on, you hit it off, it really gets you into a good rhythm as far as welding. That's not to say that you can't do it without pulse, but a lot of people like pulse looking welds because of the stack of dime looks, and it's pretty consistent. If you're not using filler, it'll be exactly the same every time depending on your speed. It's a good tool to have in the toolbox. Every tool that you have in your toolbox has a purpose. This is one of the other purposes. A lot of out of position welding, pulse helps because you can reset your stuff. I do typically do some pulse when I'm doing tubing, and the reason being is if I have my torch and I'm here, sometimes my filler rod will get out of position, so that brief second where it's going from high to low, I can actually reset myself, and it gives myself an extra bit of time. So that's one of the other benefits with pulse. For thick material, I would say the only benefit to doing it would be get better penetration because you're getting that high in there. It looks better, but it would be the same as thick and thin. The benefits would be exactly the same because you'd just be setting the machine for higher amperage. But structurally, I would say, just personal experience, and everybody can chime in on this. If I was doing thicker material, I would be using non-pulse. I wouldn't pulse it, just because there's more chance for incomplete fusion, stuff like that. There's just more variables involved in it, and I just wouldn't do it, but you can. Okay, we are going to go ahead and set this guy up for pulse. Just to make life a little bit easier, I'm going to set the amperage at 100. And as you can see, the pulse light is off. So once that is illuminated, like our high frequency, that means our pulse is on. So we're going to turn our pulse on. The very first thing you see is our pulses per second. And off the bat, you can see our pulses per second are 999, which means there's going to be 999 pulses or short bursts in 1 second. So for this case, we're going to go ahead and change that down to make life a little bit easier. We're going to go 1 burst per second, which would be right here, 1 second. It goes all the way down to 0.4 tenths of a second, and we're going to go rolling with 1 second. The next is we're going to do our duty cycle. In this case, this will be the amount of time that we're going to alternate between the two amounts of current. So in this one, we're just going to put 50 to make life easier. So right now we're at 100 amps, 1 pulse per second, 50% of the time. Next, we're going to go ahead and set up background time, which is there, and it's going to be at 25%. That's what we had it, which would mean if it's 25% of 100, it's going to alternate between 100 amps and 25 amps. So for half a second to another half a second would be 1. So it'd be 100, back to 25, back to 100, back to 25, back to 100, back to 25. So that's going to be the way it would be as far as our pulses. The way I like it, I usually set up 1.8, and that's the way I weld at. So my timing, or every time I dip, it's approximately 1.8 seconds, depending on what I'm doing. If it's aluminum versus steel, my timing is going to be a little bit different. But in this case, I have it at 1.8. My duty, usually I roll with 50%, so I alternate back and forth. And my background is usually going to be 25 to 30, sometimes 40. That's how I typically set it up. You can feel free to mess with it any way you want. Like I said, it's 999 pulses per second. Your duty can go anywhere from 10% of the time, it's going to do 1 versus 90% the other way, or it's going to be 90% one way and 10% the other way. I just like to alternate it back and forth for me. Now, you don't want to set your background current, which would be this guy, too low, because if you do set it too low, you have potentials for cracking, especially in aluminum. You can in steel as well, but aluminum more likely will crack, just because the puddle's basically so close to freezing or not being molten anymore that you can develop cracks. We are going to weld this autogenously. There's going to be no filler, and then we're going to go over, pros and cons of not using filler. One of the things I'll just tell you right off the bat is with the thinness of this material, filler is going to usually be too thick for it. So we only went halfway down with that one setting, because that was 7 or 7.5 pulses per second. We're going to go ahead and change that particular setting, but you can see in the actual weld, with the pulses per second that high, it almost looks like no ripples whatsoever. It's just like a fusion weld. Next, I'm going to change our settings. So right off the bat, you can hear the difference. And really only the difference between this weld and that weld is just your pulses. This one, obviously the flashing light will probably drive you insane, where this one wasn't as bad to go through the pulses. But right now we're gonna look at the backside. The only thing that we changed was our pulses per second. We didn't change anything as far as our background or our amperage. Amperage and all that stayed exactly the same. This was the first one we did. So with the lower pulses per second, the 7.5, I was able to keep the heat a little more consistent, mainly because when I was on the pedal, I was at 75% of the pedal, whereas the material was already hot, and then I changed it to 33 pulses per second. So when I got into it right here in the beginning, you can see it was a little shaky, and then in the middle, I was more consistent as far as keeping the heat input. But if you look at the HAZ, or the heat affected zone, on the 7.5, I was more consistent, where you can see it's even, both sides. Whereas this one, I got more heat into it, but that's just the nature of welding something right after welding it again. So I'm gonna get more heat. I bet if we went back in and actually did it cold, I would say our heat effective zone would be a lot smaller on the 33 pulses per second. So next we're gonna weld super thin razor blade, and basically we'll show you the benefits of pulse. So I'm gonna pulse weld this one, and my settings right now, the machine is set up for 10 amps, 50%, and our pulses per second is gonna be 999. As you can see, it warped halfway through, but you can see the second half of the weld look good. Switch this out and try different pulses per second to see. So just this section, the end came out well because it actually started to flow. We're gonna do one more razor blade, and we're gonna change our pulses per second, just so that you can see the difference on how it's doing it. 999 pulses per second, it was throwing me off a little bit. So on this one, it's gonna probably come out better, but we'll see. So already you could see some distortion. But this one's flowing a lot better. Razor blade challenge, y'all. So for me personally, that flowed a lot better. I think with the 999 pulses per second was messing with my equilibrium. And if you look on the back side, we got complete penetration. Next up, we're gonna do some aluminum, and we're gonna pulse it as well. The only things that are gonna change is we're gonna use the exact same pulse settings that we just used on the razor blades. It is 33 pulses per second, 50% duty. The amperage, we're gonna go up to 130 amps. I'm gonna weld this autogenous. With aluminum, typically you don't weld autogenous because it makes it weaker, especially with this thin material. If we're welding autogenous with thicker material, you can weld it autogenous and it still will be a sound weld. But with this stuff, you know, I will weld it, so I'm gonna roll down and actually weld it, and then I'll show you without filler what it's gonna do. Beautiful. We're going to flip it over and look at the back side. Penetration. But there is penetration there. Should have probably went a little hotter, that way I can get more penetration. But there is penetration there. And actually this is a good weld. So for it being autogenous and having no filler, you know, everybody will tell you autogenous aluminum will break. This will break, but as you notice, me bending it, the material itself is actually bending, not the weld, so that'll debunk that. So this one was autogenous and this was aluminum. The next one we're going to do is we're going to weld with pulse with filler rod, but this was 33 pulses per second, and I probably can't get the rod in fast enough on 33 pulses per second. And if I were to weld like this pulse with filler rod, literally I would just do lay wire, which I can actually show you on this backside of it. With 33 pulses per second, I'm going to use filler, but we're going to do lay wire. So with lay wire, which I got into a good groove here, I was a little bit off here because I was trying to avoid the camera. All lay wire is getting the filler rod on an angle like this, so you're just putting tension here. And when you're welding, you're essentially just running it over, and you'll watch it actually fall into it. So from here to here, you can see that it was a good lay wire technique. You know, all these techniques have their time and place, and like I said, it's good to have a toolbox that has everything. So I will use lay wire here and there. Really, the only time I ever use lay wire is if I'm trying to do this weld super quick. You can just run it over and get on with your day. That's why you don't really see any ripples, because the ripples are when you're putting rod in there. So the next one we're going to show is actual filler rod being introduced. I'm going to change our pulses per second from 33. I'm going to go all the way down to about 1.8, and the reason I want 1.8 is so that I can actually get in between our pulse. For the most part, I mean, it's a good weld. It looks pretty good. Some of my spacing is kind of off, like right here. I got a little shaky. But for the most part, it looks pretty good. If I did another run exactly the same, I'm sure I could probably make it look a lot better. The only thing that you can notice when you're doing pulse in aluminum is, since it is like coming on and off, you see the little white etching zone is actually in your ripples. So that's one of the things that I say that I don't like when I weld aluminum. I like it to be nice and shiny across instead of having little white halos, I guess, etching zones. But this one, I went a little cold just because it threw me off. I got good penetration here. But again, we're going to do the same thing. And you can see as well, penetration is on point. I bent the material and it didn't crack all the way down the weld. But when you're doing aluminum, that's what you kind of want to look for, depending on what you're doing. Some particular jobs are just for looks and you don't need full penetration. Obviously, if it's structural, you want to have full penetration. So things don't break. And mind you, every one of these materials that I'm using today, steel, aluminum, everything, one thing to keep in mind, none of this stuff is being cleaned. So if I would actually take time and clean all this material before I weld it, it'd look a lot better. But for this particular case, as far as educational, we're just trying to show the benefits of pulse and the benefits of other things in the machine.
Oh baby.
Yeah, this one I like a lot better because you could see from that last one, all my ripples are evenly spaced and there's no high and lows on them. And all that is just experience, really. It's just doing the weld, you know, finding what works the best for you. And you can see that I went from, you know, doing one weld that was a little shaky, and then I did the exact same weld, and the second time I was actually, you know, able to do it a lot better. And then, all right, guys, thanks. This is Gabe with HTP. We went through welding some aluminum, some steel. We went through some pulse settings. Went through the machine with you. We're gonna have a part 2 of this actual video to go into configuration, stuff like that. So this was kind of our intro to pulse. So we were able to do some aluminum. You can join me here at HTP April 15th and 16th. We're gonna be doing an aluminum class so that I can actually get a little more in depth as far as the AC waveform. We can get into some electronegative, electropositive, things that you can change. Obviously today we showed a little bit of pulse. All that stuff I'm going to be going over with you guys. It's a 4-hour class. I'll see you there.